Okay, here are your notes for the first day of Math Apps. Your PDF contains all of the problems. This is the assignment sheet. I'll come back to this in a little while. The first screen is basically definitions of numbers, which you've seen before. Natural numbers are what you naturally started counting with, 1, 2, 3. And if you throw in 0, you have the list of whole numbers. Integers are all the whole numbers with negatives added to them, so all the negatives and all the positives. And then rationals are integers over naturals because you can't have 0 in the denominator. So I can take any integer, put it in the top, and I can take any natural number, put it in the bottom to get a fraction that looks like this. This negative 1/3 is really negative 0.3 infinite repeating. So a rational number is any fraction or any repeating infinite decimal, positive or negative. Irrational are when you have infinite non-repeating decimals, and those happen in two ways. Sometimes when you take a square root, sometimes you get an infinite non-repeating decimal, and sometimes there are predefined infinite non-repeating decimals like pi and e, both of which you'll be using later. Real numbers are everything that we've talked about so far: natural, whole, integers, rational, and irrational. And then the separate system is not real numbers, and that can be broken down into two groups: either imaginary, which I'm sure you've seen before, the square root of negative 16 is 4i, or complex, which is a combination of imaginary and real numbers. We're going to talk about all those again later. And just a quick reminder of the two types of factoring methods. Prime numbers have only the number itself and 1 as factors, whereas composite numbers can be 1 times 12, 2 times 6, different combinations of prime numbers. 6 isn't prime, that could be broken down again, so we usually take composite numbers and break them down into their prime factors using a factor tree. 12 is 2 times 6, 6 is 2 times 3, 2's and 3's are all prime, so now we know that 12 is 2 times 2 times 3, or 2 squared times 3. Next screen, you're going to get a little bit of practice on a new way of labeling intervals of numbers. Inequalities and number lines you should be familiar with. Interval notation is a new thing. And if I take an inequality and say I need all the numbers between greater than -1 but less than or equal to 3 and put it on a number line, that's a visual representation. But a much more compact way is to do what's called interval notation. If I don't want to include an endpoint, I use a parentheses. If I do want to include an endpoint, I use a bracket, and then I put the numbers in increasing order from left to right. -1 is smaller than 3. Put the numbers in increasing order, and then attach the appropriate symbol. So your job now is to pause the video and to come up with the interval notation and the number line representation for these 3 remaining inequalities just in the top row. So do those, pause the video, and the answers will be on the next screen. Okay, here are the answers. So you can see that if I want the numbers between -1 and 3, but not including the borders, I'm gonna have 2 open circles, shade everything in between, and I get this. Again, the open circle gets a parentheses. If I want to include the left endpoint of -1, but not the right endpoint of 3, -1 gets a bracket, and 3 gets a parentheses. And then for the last one, if I want to include both endpoints, I'm gonna have -1 and 3 both shaded in. I'm gonna shade all the points between the two, and then I'm going to write brackets for both the -1 and the 3. And again, very important, make sure that the numbers inside are always smaller on the left, bigger on the right. For one-sided inequalities, if I just want all the numbers that are greater than, for example, -1, I'm going to start at -1, don't include it, and shade all the way up and to the right. How do I show that in interval notation? -1 is smaller than positive infinity, so I write -1 and infinity. -1 gets a parentheses because it's an open circle, and we can never touch infinity, so I can't include that, so infinity gets an open parentheses as well. Second one, x is less than or equal to 3. I want 3 included. Everything below that is negative infinity, so that's going to be written first. Negative infinity is smaller than 3. Can't touch infinity, so that gets a parentheses. You do want to include the 3, so that gets a bracket. And then finally, for compound inequalities, if I see something like and or connecting 2 statements, I'm going to just plot them separately. Numbers that are less than -2, open circle at -2, go left. Numbers that are greater than 3, greater than or equal to 3, closed circle, go to the right, and now convert that into interval notation. Negative infinity is smaller than -2. Can't include infinity, so parentheses, open circle is parentheses. The math notation symbol for or is a U. And then for the last part, the second half, include the 3 with a bracket and go up to positive infinity with the parentheses. So moral of the story is if you have one-sided inequalities, the infinity symbol always gets a parentheses, and it never uses a bracket. Okay, two more quick screens, both involve absolute values. When you were in middle school, absolute values hopefully were pretty easy. What's the absolute value of 3? That's 3. What's the absolute value of -3? That's 3 as well. So absolute value just means to turn the value positive. But in algebra, if we stick a variable here, we don't know whether that variable is positive or negative. So we've got to come up with two different branches or two different outcomes. If I take the absolute value of a variable, I've got to say, well, if that variable was initially positive, I'm just going to write down whatever number I saw there. But if that variable represents a negative number, then I need to take the opposite of that negative, because the opposite of a negative becomes a positive. And you'll see how that's handled over here on the right. I have this double absolute value statement, and I want to evaluate it, but I'm told that my numbers for substitution are going to be between -2 and +1. So the x's can be negative or positive, but when I plug them in here, I need to figure out whether or not each absolute value interior is positive or negative. So I'm going to pick a number between -2 and 1, and I decided just arbitrarily to try -1. If I plug -1 in here, I get negative results, because -1 minus 2 is a negative value. And if I plug -1 in here, I get a positive result. Once I know that this part is negative and this part is positive, I go over the rules here. Negative, you take the opposite of the statement inside the absolute value bars. For positive, you just rewrite it. Now I simplify. Distributing the negative produces -x plus 2. Adding on x plus 3, nothing changes here. Simplify the algebra. The x's happen to cancel out, and I get 5. Now, what I need to warn you about is this doesn't always happen where the x's cancel out. X's do not always cancel out. Substitution is only going to work sometimes. So notice I didn't plug in -1. I tried -1 and wrote down whether the result was positive or negative. I did not substitute in -1. And the last thing is, why do we have absolute value? Well, absolute value really helps us with distance. In this definition here, it says distance between 2 points is a minus b inside absolute value bars. So if you get that memorized, these are really pretty straightforward. If I want the distance between -3 and 7, the part that's always there are the absolute value bars and the subtraction. Okay? And then I'm just going to substitute in the two numbers I see, -3 and 7. Now you could put the numbers in the other order, so I could say, well, that distance is also equal to absolute value bars with a minus. I'm going to change the order. I'm going to put the 7 first and then -3 second. If you were to actually finish these, and they just ask for an expression, so you don't have to finish it, this would be -10, this would be +10, but the absolute value of -10 is 10, and the absolute value of +10 is 10, so they both produce the same number in the end, but they just ask for an expression. So, last example, all right, an absolute value expression for the distance between a and -5. Absolute value expression is always absolute value bars with subtraction. Pick up the two things you're looking at, a and -5, and you could rewrite that as a plus 5. Or if I did it in a different order, absolute value bars with the subtraction, I'm going to put the -5 first in the a, and that's the same thing as -5 minus a. Nothing to simplify there. Okay? So that's the definition of an absolute value and distance. Those are pretty straightforward, hopefully. All right, and this last thing down here is just to remind me to show you about your homework. These are the notes for the first day. If I go back to the assignment page, your first assignment is day 1, which is all that. There are 3 titles there: real number system, interval notation, and absolute value. If you notice these numbers here, problem 1, problems 27 through 29, etc., are all at the top of each page. So after you look at the notes, if you do that problem number 1, you've done all the problems for this topic. If you look at this page, you see a whole bunch of numbers here. These are the notes for those problems there, and same thing for the absolute value. These 2 pages on absolute value, 1, 2, have those problems assigned. So you can get the homework either from the top of the notes page, or you can go back to the first assignment page and know that you have day 1. All right, that's it.